Hello students, today we'll discuss residuals and error terms in regression analysis. We often use these two terms while conducting the regression analysis, but students seem confused that what are the residuals and what are error terms and what are their uses. In today's discussion, in today's video, I'll try to explain to you the residuals and error terms and the difference between the two. Today is the lecture number 35, the regression series part 4. I am Dr. Muhammad Zaheer. Let's see what are the residuals. In regression analysis, residuals are the differences between the observed values of the dependent variable and the values predicted by the regression model. These differences represent the errors or unexplained variability in the data that the model couldn't capture. Residuals help you assess how well your regression model fits the data and whether there are patterns or trends in the errors. How you calculate residuals in regression analysis. Step number 1 is fit the regression model. First, you need to build a regression model using your independent variable or variables to predict the dependent variable. The equation of a simple linear regression model is y equal to beta naught plus beta 1 x plus epsilon or error. Y represents the dependent variable, beta naught is the y-intercept, beta 1 is the regression coefficient, and x is the independent variable, where epsilon represents the error term. Then calculate the predicted values using the estimated coefficients from your regression model. Calculate the predicted values for the dependent variable y hat for each data point in your data set. This is done by plugging in the corresponding independent variables into the regression equation. And then step 3 is calculate residuals. Residuals are denoted by E. These are calculated as the difference between the observed values of the dependent variable y and the predicted values y hat from the regression model. E is equal to y minus y hat. There are many uses of residuals. For example, model evaluation. Residuals are fundamental tool for assessing how well your regression model fits the data. A good model should have residuals that are close to zero, indicating that the model is explaining most of the variance in the dependent variable. For checking the assumptions, residual analysis is used to check several assumptions in regression, including linearity, homoscedasticity, constant variance of residuals, and independence of residuals. Violations of these assumptions can indicate problems with the model. Then residuals are used to identify the outliers. Large residuals, either positive or negative, may indicate outliers or influential data points that have significant impact on the model. Identifying and addressing outliers is a crucial part for model development. Improvement and iteration. By analyzing residuals, you can identify areas where your model may be underperforming and make improvements. This could involve adding new predictor variables, transforming data, or using a different regression technique. Then predictive power. Residuals can help you estimate the uncertainty in your predictions. Smaller residuals indicate that the model is making more accurate predictions, while larger residuals imply greater uncertainty. And then model comparison. When comparing different models, you can use metrics like mean squared error or root mean squared error, which are based on the residuals, to determine which model provides a better fit to the data. So in summary, residuals in regression analysis are the discrepancies between observed and predicted values, and they serve as a critical tool for model assessment, diagnostics, and improvement. Analyzing residuals helps you ensure the validity and reliability of your regression models. and this is a regression line. The traditional regression line is y hat equal to, this is the predicted line, y hat is equal to bx plus a, or you can call it a plus bx, and this is the line fitted, and these are the residuals actually which are away from the regression line. So these are below the regression line and these are above the regression line, and from each point the distance of that point is basically showing the error, that is y minus y hat. Larger the distance, poorer is the model. So we have to see how many points are closer to this line and how many points are away from this line. Now let's take an example. We have two variables x and y. X has the values 5, 1, 4, 7, 6, 4, 3, 2. Y has the values 10, 4, 5, 11, 15, 6, 5, 0. And when we have predicted the value of y, the y hat or the regression equation is 2x minus 1, and by multiplying every x with 2 and subtracting 1 from it, we get y hat values. See, this is the x multiplied by 2, 5 into 2 10, 10 minus 1 is 9, 2 multiplied by 1 minus 1 is 1, and similarly all other values. And from each y value we subtract the y hat value or the predicted y value. See, from 10 we subtract 9, it is 1. From 4 we subtract 1, it is 3. From 5 we subtract 7, it is minus 2, and so on. So these are the residuals, y minus y hat. So these are actually the residuals which we have calculated. First we fitted the model, and then we calculated the predicted values, and then we subtracted each predicted value from the y value. That gives us the residuals, and then we can square these residuals. You can see the sum of the residuals is always 0, and the distance between the actual data point and the predicted point on the y is defined as y minus y hat, which is the error, and that I also showed you on the graph. Now let us do this exercise in SPSS so that you come to know how we calculate these values. This example has shown you the manual calculation. Let us see how SPSS calculates all these values. We have a file named residual analysis. Go to analyze, regression, linear, take y in the dependent variable and x to the independent variable, and press save, and click these two unstandardized predicted values and unstandardized residuals, and press OK, and see we have this model. We have used entered method, and this is the model summary. This shows that the value of r, that is the correlation coefficient, is 0.84, and value of r square is 0.718, which means that if we multiply it with 100, 71.8% of the variation has been explained by this model, and rest is unexplained. This model is significant. If you see this ANOVA, and you can see the coefficients table, and this shows us this is the constant -1, and this is the beta 1, that is the regression coefficient of the independent variable x, and that is 2. So our equation becomes this y hat 2x minus 1. This is our regression equation. Actually this is like this, or you can write it y equal to minus 1 plus 2x or y equal to 2x minus 1, whatever you like. The result is same. And then you can see that there are some new variables created in the data file. This is predicted value and this is residual value, and you can see if I minimize this, so this is the equation. You can see this is x 5 1 4 7 6 and 10 4 5. These are the x values and y values, and you can see the predicted value is that is predicted that we saved in the while asking SPSS to run regression for us. This is 9 1 7 13 11 7 5 3, and these are the residuals. So this is the way we calculate the residuals in SPSS, and this is the way then we check the residuals and we fit the line, and after that we run certain assumptions, the certain tests on the residuals. These are the residuals actually. That is what I'm more interested to show you, where we are going to apply the tests or test of homoscedasticity and other tests that we are going to apply. Now you must have heard the other thing, that is the error terms. So I want to tell you what is the difference between residuals and error terms. In regression analysis, both error terms and residuals are important concepts, but they have slightly different meanings and are used in different contexts. People say that these are same thing, but these are not same thing. They have a little difference. First of all, you must remember that error terms or the epsilon is used for the population, whereas residuals are for the sample analysis. That is the first difference. Then let's see, we have already seen residuals are denoted by E, known as the residual errors, or simply residuals are the difference between the observed values, actual data points, and the predicted values. And this was the formula we already have seen, residual equal to observed value minus predicted value. Residuals represent the unexplained variability in the data by the regression model. In other words, they capture the discrepancy between actual data and what the model predicts. And error terms, which are often denoted as epsilon, are the theoretical concepts in the context of regression models. They represent the unobservable inherent randomness, noise, or variability in the relationship between the independent variables or the dependent variable. The error terms are the theoretical constructs assumed to follow certain statistical properties, such as being normally distributed. And error terms represent the difference between the true underlying relationship and the observed data points. And error terms are not directly observable, as are the residuals. The error terms are not directly observable or measurable, but they are assumed to account for the unexplained variation in the dependent variable that cannot be attributed to the predictor variables included in the model. For example, 71.8 was the explained variation in our model. Rest is unexplained, and that is the error term. The regression model assumes that the observed data points are generated as follows: observed values equal to true relationship plus error. True relationship represents the deterministic part of the model, and error represents the random component. Let's take an example. Suppose you are studying the relationship between the number of hours studied, which is independent variable, and the exam score, which is dependent variable, for a group of students. You collect data and fit a simple linear regression model, and exam score is equal to beta naught plus beta 1 multiplied by r studied plus epsilon, the error term. So residuals would be, after fitting the model to your data, you calculate the residuals for each student by subtracting the predicted exam score from the observed exam score, as we did in the previous example. And error terms. The error terms or epsilon represent the unobservable underlying variability or noise in the relationship between R studied and exam scores. They are not directly observable. Let's see, these error terms account for factors that the model doesn't capture, such as individual differences in learning abilities, test anxiety, and other unmeasurable influences. So you must have understood that error terms are not part of the model. They are actually the noise, the random errors which are present in the model, which we are not directly capturing, and residuals are the errors which we are capturing, which we are measuring. So theoretically error terms are always there, because there has never been a model which can 100% predict the dependent variable. So there is always unexplained variation in the dependent variable, and that unexplained variation is attributed to error terms, and error terms are constructs and theoretically present, not measurable. I hope you have understood the both concepts. In summary, residuals are actual differences between observed and predicted values, while error terms are the theoretical constructs that represent the random and unexplained variability in the relationship between the variables. Residuals are used to assess goodness of fit of the model, while error terms are essential for making statistical assumptions and for estimating model parameters using methods like ordinary, least square, regression. I hope the how you must have understood the concept of residuals and error terms, and how we calculate the residuals. And in coming videos we'll see how we apply the analysis on the residuals. Till then, take care. Thank you very much.